Hello everyone. Today we're going to take a look at another program that I wrote quite a long time ago because I want to review some software and I think it's going to be interesting. This one's quite interesting. It's, as you can tell by this immense fucking picture that I loaded in here that I do not own the rights to. Um, let's uh, let's clone this repo and see what's going on. So a little bit of backstory. I'm a guy who likes to play games, right? And like any guy who likes to play games, I wanted to always just make my own game, right? And maybe that's just me. I'm not sure, but so I figured, how do you make your own game? And so you do usually do that by just like getting a game engine and just kind of getting into it. But turns out a lot of people will tell you, "Oh, make your own engine." So what I did was I sat down and made my own engine once or twice or whatever, and this is one of them. No clue which one this is or if this is any good or I think it compiles. That's about all I know. And I've looked in a few files and it looks like pretty reviewable. So let's get into it and see what it is. It's mostly C++, a little bit of shader code, and that's kind of it. So let's see. Okay, we got what have we got? Let's just look what files we got. So we got a bunch of files. They're not in any subdirectory, which is fucking horrible, but let's pretend that's not the case for a second. There's some shell scripts. And this is something that I and other beginners often do. So let's look at them. So yeah, this is horrible. Okay, so the reason people do this is because they don't quite understand how to use their make tools or their tools, and so they just kind of do this, make a little build script and just sort of see what's going on, and they like bunch together documentation that like, oh, I guess I have to do this, and don't really bother to explain it, or to like have it explained to them or to understand it is what I meant. And so in this case, you can see that this script is hard coded to basically go to to go to the bin folder, remove dungeons so that it rebuilds. That's probably the name of the executable, I'm guessing. Then runs cmake like this, which is kind of goofy, and then runs make, which is also kind of goofy. So the first thing we're going to do is we're going to talk a little bit about build systems. So build systems like CMake's a meta build system basically, but build systems like make allow you to write a bunch of rules so that you can compile code according to rules, so that you don't have to go, compiler, whatever it is, like GCC or whatever, all my CPP files, then you suddenly got, like all of these, and then all your headers maybe as well, because you feel like it, and then game, right? And it doesn't work because you don't have all the things. So you need to be like, oh, it's standard C++ 17 or something. And you're like, oh, well, it still doesn't, like it's just, I don't know why this doesn't compile, by the way. We'll look at that in a second. I'm just saying, like, you don't want to have like these massive incantations of your compiler. So, and this will recompile everything every single time. So instead you write a make file. But make files are kind of ancient. And the problem with those is that you also, you're limiting yourself a lot to a specific build tool, in this case, make. And so other people might prefer Ninja, or on some platforms, make works a little differently. Like on BSD-based platforms like macOS, FreeBSD, you will have not GNU Make, but a different make, I don't know, BSD Make or something, and it behaves slightly differently. And so while the syntax is probably mostly the same if you stick to simple stuff, there is a lot of stuff that you can fuck up. And so instead, people came up with CMake. And CMake is great because CMake lets you specify like a meta build system, like here are my files, here are my libraries, and then it will generate a make file or a Ninja build or whatever you want. And that's awesome, right? Because you don't have to worry about it. It just kind of does it for you. It can generate like Windows, like Visual Studio solutions. It doesn't care, right? It's great. But you have to learn how it works because it is a beast, and much like C++, it's kind of a piece of shit. So you kind of have to navigate around all its weird edges and pit holes and fucking You know, here and there you'll run into a black hole and get sucked in and die. And that's exactly what probably happened here, because this does not look great, to be honest with you. Um, this is a terrible fucking CMake. But okay, I'm just being so harsh because it's my own code, but this is what I think when I see stuff like this, regardless. So let's get into it. Oh my fucking god. Okay, so it looks like what we're doing here is we're doing dependency management ourselves, which is very goofy. Let's look at that. Let's look at get dependencies. Okay, so it has scripting functionality. I don't remember building that, but sounds good. So let's look what the README says. The README says read dependencies.md. Oh no, do I have to install stuff? Okay, I need to install SFML GLM. I think I have that. I don't have perms in this shell, so let's go. Do I have GLM? Yes. Do I have SFML? Let's see. Yes. Okay, awesome. So I don't have to worry about those two. They're already installed. What else have we got? This is such a cringe. Okay. And we have to run get dependencies. So let's make sure this doesn't suck. Okay, that's fine. Is it executable? Yeah. Okay. So let's run that. Okay, wonderful. That worked. And to be clear, shell scripts are okay, but shipping them with your repo is a little weird. And if you have a get dependencies one, that's even more weird. And I mean, if you guys want, I can make a tutorial on how to properly do dependency management in C++ with VC package. It turns out to be really easy. You basically just have a file similar to npm and other stuff where you just specify what your dependency is, and it will fetch it for you via CMake. So you invoke CMake, and CMake will fetch dependencies and stuff like that for you on all platforms that your dependencies support. So it's really good. And I think we should all like aim to use stuff like that more, because this type of shit I see way too much, and not just from beginners. And especially if it's a bigger open source project, like maybe someone like me 5 years ago when I wrote this, their project blows up, and then suddenly it's this type of shit is in a big project, and that's not acceptable in my opinion. But let's keep going here. So we have dbg.sh. That's probably just, oh my fucking god. So what this, okay, so this builds it in debug, I guess. That's really weird, honestly. I mean, so this already builds it in debug type. Although this is not cross-platform, but yeah, let's look at this a little bit further. Let's review this build system stuff first, because it's actually very interesting, and then I might make a second video about the actual code, but we'll see how long this takes. I just don't want to bore you guys too much. But okay, we're setting the C++ standard to 17, which is pretty acceptable considering this was released in 2019, so makes sense that it would be 2017 standard. Then we have include directories. That's fine. That's okay. This sucks. This seems to be a workaround for like building a static executable, which is kind of hard on Linux, kind of good, kind of silly. And this also means that on Windows it would also do that, but yeah. Then we've got this. We got a big old thing. We got some bunch of files, some headers in here too. Okay, then we rely on SFML, we rely on STT C++fs, which is not supposed to be there. Gotta be honest, that's part of the standard library by C++17. But okay, pthread, that's not a good one. So pthread is POSIX threads, right? And POSIX threads library is only available on POSIX systems, right? So you're gonna have a hard time running this on Windows. Same with X11. And GL might also be an issue depending on your platform. So, and that's fine, but SFML should pull in these dependencies. And if it doesn't, then first look to SFML for what the fuck are you doing? But I'm presuming that the reason it doesn't pull these in is because these are pre-installed on the system and they're not shipped like with VC package, which would pull in the dependencies it needs. So, but let's one thing at a time. So, there is a thing here with pthread, right? So the reason you need pthread is if you use threads, you need platform-specific library stuff to be linked in on some platforms. For example, on Linux, you will usually need pthread to be linked in manually. Now, the way this works is usually with a flag that's dash pthread instead of linking to pthread, which is a little weird. But yeah, let's not get too far into this. But basically what you want to do in order to find the threads library for your system is something like find threads, or is it include? I think it's include find threads, something like that. And then you get a target that's called threads. So this just lets you basically link to the platform threads instead of the whatever else, right? And that should also work. But let's just get back to the original, just because I want to stay true to this. And I don't think we need a second episode for this. We'll see. Because that's about all the review I'm going to do. And I'm going to show you how to invoke CMake properly, because I'm not going to run these scripts. That's just not great. Let's make sure the bin folder is no longer there. And let's run CMake. So CMake, then you give it the source directory, then you give it the build directory, give it the mode, like the type, and that's kind of it. I also want this for my own stuff. This, you don't have to do this, obviously. And yeah, I just need to do these two little commands for my own NeoVim setup, because I can't be bothered to set it up properly. And then we basically just do CMake -- build bin -- parallel. And if you're on BSD, you need to provide a number here, but we don't, because on yeah, it's fine. Okay, so it looks like standard file system really doesn't exist here. So let's go and look at that. So global.h doesn't seem to be importing file system, so let's do that. It's like one of those new, sort of mistakes where that was probably the whole reason that I had standard C++fs in there, and it's just super goofy in my opinion. Okay, so it's trying to link against stuff that it doesn't have. Where is SFML? Window.so. Yeah, it doesn't exist. Okay, so I'm gonna take some time to install these and fix the build system, and I'll be right back. Okay, I've got it to work. There was just some weird code that I had to remove because it was just, I don't know, trying to init X threads, even though there's no fucking reason for it. So excuse my language. So let's run it as my main user, and I'm gonna pull it up on screen really quick here by switching the sources to this. How epic is that? Okay, so this is the dungeon game apparently that I was trying to make, or I don't know. You can zoom in and out. I kind of remember that. You can move around, which is, I think WASD, yeah. And yeah, that's kind of it. I mean, I guess I get it. It's, it's a thing, I guess. It's kind of cool. I mean, you have sprites here. You clearly have some sort of thing that puts the sprites together in a nice way. You've got a shader going on. I mean, there's no gameplay, but I guess that's fine. If I zoom out too much, it's probably gonna break, or if I zoom in too much, it's probably gonna break. But yeah, kind of cool. I mean, yeah, let's get into the code review though, because it is time. It really is. So I've wasted way too much time trying to get that to work. But yeah, okay. So let's start with the main.cpp file. And the main.cpp file is fascinating, always, for those projects. This is the line I had to, this is the line I had to comment out. Also, I remember someone last video was like, yo, why are you using your mouse? It's Vim. Yeah, good point. Let's not use a mouse. So yeah, extended threads, kind of goofy. We don't need it. So let's remove that. What have we got? We're creating an SFML render window. If you're not familiar with that, that's okay. It's not a biggie. That's just creating a window. No vsync, which is probably why my PC was fucking screaming when I ran it. That's a lot of FPS, I bet. We've got a camera. Okay, we've got a camera object of some kind. Got a collision engine, a resource manager, a renderer, and a world. These are all unique pointers. That's kind of nice. What's not nice is that they are globals, but that's, I mean, it's a game engine. You get a little bit of leeway there in terms of what's good and bad practice. I mean, it's not bad practice if it works, right? So, I mean, that's totally wrong, but whatever. We can apparently pause the game. Interesting. I didn't try that. We have a main loop right here, just raw dogged it into the main function. Okay, I guess. What else? We've got key handling. All right. Okay, looks good to me. There's some stuff here that apparently is to do, so that's fair enough. Oh, here it is. GRenderer render. I guess that's probably what's rendering the screen and everything on it. I would hope that this is some sort of scene graph, but I very much doubt that I built a scene graph 5 years ago. So let's see what it got. We got some zoom for the camera. We got okay. Oh, okay. So I guess these pass the key events down. Fair enough. So let's go up and have a look at the render function because that's actually very interesting to me. And as we actually know, let's look what all the classes we're building up here because these are probably the most interesting cases. So collision engine. Yeah, so as we could see in the demo is that we could run into walls and stuff. So there must be some sort of collision resolution. Okay, looks like there's rigid bodies. That's an interface. I don't like that, but sure. Rigid body ID is just an unsigned long. It's a little weird. This should probably be some other type. But yeah. What have we got? Register rigid body, unregister rigid body update. So it looks like, and maybe I'm wrong, but it looks like we're registering them in a data-oriented way. We're basically saying, okay, you get an ID if you give us a rigid body, which is a raw pointer. We'll have to see why that is. And we return the ID, which is just the index into some rigid bodies array. That sounds good to me. Then unregistered does the opposite, just basically erases it and returns true if it erased it. Collides is AABB collision. This sort of thing should have a comment. I don't know why it doesn't. This should be like, is it even here? Where is it? Is it a free function? That's a free function. Okay, so it should have like, AABB collision. Just because, if someone else reads this who hasn't seen AABB collision before, like, how are they supposed to know? But yeah, it's AABB collision, which is basically just a bounding box. Like you have two bounding boxes and they collide. They're rectangular. It's very, very simple math. Don't need to get into it, I don't think. What else have we got? Handle collision. Okay, oh my god. At least there's comments here. So I guess the collision resolution works by correcting for the overlap, I guess. So if you do overlap, it will correct it out depending how far you overlap. And you're just hoping that it doesn't overlap too much. I guess that's fair. I think that's pretty standard. I'm not entirely sure if that's a thing you usually do. But this is like the naive implementation, I guess. And so that's fine because this is a learning project, obviously. That should be fine. Moving the rigid body and setting its velocity based on this prevents gaining velocity while running against the wall. That's actually pretty good. That's probably something that you could easily do in some implementations. Okay, so this seems pretty reasonable. Okay, this I don't know what this else is doing, but yeah, that sounds pretty reasonable. Let's go to the next one. Oh, let's go back to main CPP. What else have we got? We got a resource manager. Good comment. That's good. Good comment. It's kind of weird to compliment me 5 years ago, but yeah, good comment. I mean, this is solid. What have we got? So invalid ID is 0. Okay, fair enough. Most of this is probably just SFML wrappers, like wrappers around SFML stuff. Let's check. Let's see. Yep. Yeah. Okay. So that's not that interesting. We're basically just wrapping around stuff. The vertex shaders are probably also just wrapping around SF shaders. Yep. Yeah, exactly. So also I'm using the mouse here to show stuff because otherwise I can't like jump around that fast to show stuff. I'm not that good at Vim. I like the logging. The logging is pretty good. There was a lot of logging when I ran the code before. I don't know where it is. Let's run it again and see what happens here. So you see like loading, blah, done, loading shaders, loading fragment shaders, loading blah. It's just nice to see some sort of feedback of what's going on for the user, I guess. All right. I don't think we need to look into this further. That's probably not that juicy. What else have we got? So I mean, okay. So the idea of a resource manager would be, in my mind, to reload stuff and to make sure that you can hot reload things. I don't see any of that code here, and I'm pretty sure it doesn't support it. I don't ever remember building it, but this is one of the things that you would want a resource manager to do. Oh, let's see. Oh, it is. Oh no, it does. I think it does. Oh, cool. Look at that. Yeah, this is one of the things that you want the resource manager to do, is that if you change a texture, you want it to hot reload it into the game, recompile the shaders, whatever you've changed needs to be recompiled, or whatever processing you need to do, and sort of live reloaded. And for that, it's good to have a sort of manager class where, manager classes are kind of ass for other reasons, but it's good to have some sort of thing where you get back a handle to a texture. You're saying basically this handle represents the texture that I'm supposed to be drawing here, and you don't actually hold on to the texture. And this is some sort of going into the direction of data-oriented programming and game design, where you hold on to IDs of stuff instead of actually holding on to stuff, because that gets rid of the ownership concerns of holding on to references. So you can hold on to an ID. Of course, the ID can be invalid, but that's not as dangerous, because the only thing you can do with the ID is give it to like some function, and as long as those functions check that the ID is valid, you're good. And so effectively, you get a safe-ish handle to a texture, and the texture can change. The texture can be swapped out for a different texture and stuff like that, and you don't know about it, which is amazing for development stuff like hot reloading textures. You basically just tell the renderer, okay, grab the texture with that ID and render it here. And so if the texture changes, it might lag a little bit because it has to like reload it or something. But effectively, you don't notice that it's like auto hot reloading them or whatever, which is nice. On the other hand, I'm pretty sure that this is not very optimized, because you do always fetch the texture. I'm not sure about that. It just seems like there's some sort of problem here where like the texture is in the GPU and you're changing it, and it has to be like reloaded into the GPU. I don't know. That seems a little funny to me, and I think that it's not the most optimized thing in the world. But I'm not that familiar with SFML anymore. I haven't programmed in SFML in a while. I do OpenGL and stuff like that now. So I don't do game development anymore. But if I did, I would use OpenGL or Vulkan. So I'm not big on SFML internal, so I can't tell you exactly, but I'm pretty sure that there's some problem with that. But for development, it's fine. And it's great that this supports it. And you can see this interface that I was talking about right here, where you get the texture ID based on some sort of file name, probably. Let's see where this is called. Texture ID. This is being called in a bunch of places. Let's just go to one of these, like the renderer, somewhere in here. Yeah, okay, so we're basically telling the resource manager to give us the ID for wall inner corner top right, which is probably one of those corners of the walls that we saw that were like sort of rendered nice. I'm like gesturing with my hands, even though my camera isn't on. This is great. And effectively we're pushing that into some sort of array, and then rendering the array or something. Yeah, so this is already a little optimized. This has vertex array objects of some kind that it's building here. It's building them every frame, which is could be better, but I guess since it's a 2D game and I haven't profiled it, I don't know what's terrible about this. And if you guys want, we can do like a whole profiling series where you send me code, or like I grab random code and I profile it, because I do like high performance C++ here and there. but yeah, it's just fun to see like, you know, what takes how much time, and it's usually very surprising. But I'm not going to do that for this engine because I don't actually think that it matters. As long as it runs at about 60 FPS, anything goes, at least in game development, as far as I'm concerned. I mean, I am sort of in game development, but yeah. Okay, so this seems like it's the render function, so we might as well look at it like the render stuff. The renderer is created with a window, and then it has a mutex. Okay, that's not great, but I guess this is multi-threaded in some capacity, so that's fair enough. We got a clock here. We got all the tiles. Yeah, okay, so it's a tile map, so there's no I guess this whole engine is based on the idea of rendering 2D dungeons, so there's no general purpose engine, and this is generally what you want with an engine like this. Is you want it to be specific, right? If you're making your own game engine, don't make it general purpose, because then you're just making a shitty version of Unity, and yeah, that's not great. Unless you do it a lot, and then suddenly you have Godot, which is good again. But you don't want to like make a general purpose engine. You don't want to build in too many things, because you risk losing track of what you actually wanted to make. And the only benefit of making your own custom engine like this is the optimizations that you can get that are specific to your game, both in terms of like code readability and like sort of architecture of your program, as well as performance, memory considerations, especially stuff like cache performance. Like in this game, for example, if you know that any game that you have is going to be tile based, you can build your entire world based on tiles and chunks of tiles, and you can really optimize that for cache efficiency, for example. I've done that before for different little projects, and you can't do that very easily with big game engines where you have to have everything, for example, as like the sort of what is it called, like an object component system, entity component system in ECS, like Unity. You end up having to do everything as a game object. So either every tile is a game object, and then every tile has like a render component or something, but that ends up being very slow. So you really just want to make one big game object with a bunch of components, and one of them is like your tile map component or something. It gets really like you start building stuff. If you build a general purpose engine like that, you start building stuff that's really that goes against the spirit of how you're supposed to build stuff in that engine, and you run into a lot of little edge cases and like things you can't really do properly, or maybe the engine doesn't understand what you're trying to do, and it's not very optimal for performance or for code readability and things like that. So I think it's reasonable to build your own engine if you have very clear requirements. Like, I'm going to do something that's not usually something people do in big engines. Like, I'm not going to do a first-person 3D shooter game because Unreal is the engine for that. Like, if you do that and you build your own engine, you're kind of a goofball, in my opinion. Or Godot or whatever, you use one of those if you're doing something like that. All those engines are basically built for like first-person or third-person 3D, pretty looking games. But if you have a very specific thing in mind, like a 2D side scroller, or like a specific type of rendering technique for 3D, like for example, if you're building Minecraft or something, then it is reasonable to build your own engine, in my opinion. Long story short, I'm kind of happy to see the super specific code in the renderer, because that is exactly the only reason why you would build your own engine other than for fun, right? Only one player makes me kind of sad as someone who builds a multiplayer game. I don't think we should have a single player here. I think this should be generalized to n players or n entities that can move around, and adding enemies to this is going to be a pain because you're going to have to basically generalize this at some point. And I'm betting that player is a very specifically, this is super specific, so not sure if that makes sense. I see a void pointer wrapper and I'm not happy about it. Let's see what that is. Okay, so this is basically something that wraps a render ID as a pointer. Okay, not sure what the fuck that's about. It seems a little weird, but I have to try to. Oh, what does it say? Submit should take ref counter pointer, make sure resource can get auto. Yeah, okay. What does it actually do? Oh no. Yeah, okay, so this is really goofy. Um, I know what it's trying to do. It's trying to like do the same ID system, but it like when I wrote this, I wasn't really sure how to do it, so I just made it like a pointer wrapper thing for like a void pointer, but that like it's always a render ID, so yeah, a little weird. This should be some sort of other type, strongly typed thing. Like probably just a render ID in this case. Not sure why that's a thing, but sure. Also, this will fail, right? Is V-Arrays, is that a map? Yeah, that's a map. Okay, so there should be an unordered map from just because that should be the default. I know that map is easier to type, but unordered map is the one that you want to use by default unless you know you don't want, unless you know you want an ordered map, right? That's what these should be. They should be map and ordered map, but instead they're map and unordered maps. And yeah, basically you don't want to use a map here unless, of course, I mean, I'm using an unordered map here, so I'm not sure why this isn't a map, but I'm gonna assume there's a really good reason for it. But this access is kind of weird because it will create. That's one of the quirks, right? One of the quirks of array access with this operator is that you create the object if you access it and it doesn't exist, and that's not good semantics. You don't yet generally want this. You want to use add here, and you probably want to first before doing any of this casting stuff is we don't have contains because we're not in C++20, so like it's like find and then this. So find is not, well, if that is raw V-Arrays, and then you want to return some sort of invalid ID like that. Yeah, I guess, but not great, honestly. I would change that. Okay, what else we got? We got so based on what you're trying to submit to the renderer, it's gonna do something else, which is great already, to be honest. I like that. This is the wall rendering stuff. It's fair. It works. You write it once, it works. It shouldn't be hard coded what textures these are. That's a really terrible idea, but I guess it's just in the middle of development that I stopped developing this, so I guess that's fair. What else have we got? We got yeah, texts, I guess. No, tiles, not titles. Okay. Oh yeah, so this is the one I talked about before, where we build a vertex array. And then we basically build up a vertex array with a shader and the textures and all that. We make one, we put it into the M tiles. Yeah, kind of weird, gotta be honest. And of course, this has to return a render ID because the whole idea behind this is to you submit something to the renderer and you get a handle back about the thing that you've just submitted. But maybe it doesn't work properly because we're batching stuff together, I guess. A little weird. A little weird. This kind of just sums up this whole thing. Submit player. Pointers. Again, no pointers, please. We don't like pointers. Yeah, we don't. I don't know what this is. I don't know what the semantics are of having null player, but I'm pretty sure it's just gonna crash if we set the player to null. So I don't see the point of having it be a pointer. It should be a reference or a shared pointer or a unique pointer or an ID. Again, stick to one paradigm, I guess, but not this. Yeah. What else have we got? We got rendering. Oh, there's a render mutex here. Okay, this makes sense because you do want to make sure that nothing else can modify like stuff you're rendering while you're rendering it. So say you're rendering a texture and halfway through rendering it changes. Bad example, but pretend it makes sense. Then it will be weird. It won't be like, I mean, either you're like drawing the full texture that's like the old one, or you're drawing the new one, but you're not drawing exactly what you should, right? Or I don't know, you're changing the player's position as you render. So maybe the player is rendered at the right spot, but then later the position is different, so you render the player's shadow at a different position or something like that. There's like a whole bunch of problems with that. Not to even begin to talk about the fact that this is undefined behavior, to even have stuff that you can access from different threads. But yeah, so but this is not done well because the mutex lock is not actually going to do anything like this. If you only lock the mutex in one place, and this is the only place in the file where it's being locked and unlocked, then it doesn't do anything. Mutexes are like synchronization points. You only, like, you need to use them everywhere if you want them to work. So realistically, every single one of these functions should lock and then unlock and stuff like that. One other issue I see with just locking it, like fucking raw dogging it like this, is if we return anywhere in here for some reason, then the mutex doesn't get unlocked. So we don't want to do it like this. The fix to making this multi-threading safe would be to use standard unique lock or scoped lock or something. We can use unique lock because we're C++17. We just call it lock and we take the mutex. Where is it? Render mutex. Yeah. Okay. So, and what this is, it uses RAII to unlock the mutex once it runs out of scope. So if you for some reason return right here, it will unlock the mutex right here. Or if you exit the scope via an exception, if one of these throws, then mutex also gets unlocked, which is behavior you want, and there's no real other way to get this unless you put like a try catch around everything and stuff like that. And then you also want this everywhere. So in every single function that modifies something render related, you want to lock the mutex. And there's multiple reasons for this, but if you make the assumption that everything is going to be multi-threaded, then you must make sure that you consider that everywhere, right? You can't just be like, oh, this won't be called multi-threaded, but this will. No, everything has to be considered to be multi-threaded because you never know what some other guy is going to come in and change, and then suddenly you have undefined behavior because your stuff is being accessed from a different thread while you were looking at it. Yeah, so I would recommend stay away from multi-threading unless you know what you're doing, unless you really have a good reason. But if you do multi-threading, use mutexes liberally, but you have to be aware of some things. Adding mutexes here, for example, if I lock it here and then I call another submit function like this one, then it will be locked again, which for this mutex, because this mutex is a normal, what is it? A normal mutex is gonna not lock itself, like it's gonna deadlock and never unlock. So for this sort of use case, maybe you want a recursive mutex, so you can allow that. But yeah, if I should make a series about how to do multi-threading in C++, I can do that, because I maintain a very much multi-threaded app that's written entirely in C++. But we don't have to do that if nobody cares. Yeah, so there's, and this is the only part where I've seen a mutex, and knowing that other stuff in this game is multi-threaded from what I've seen, like the thread that hot reloads textures, kind of scary without mutexes everywhere, or some other kind of synchronization primitive. I mean, there's other ways you can synchronize, obviously, not just mutexes. You can have lock-free stuff if you need it. You can use boost synchronized value to abstract away. There's multiple things you can do to fix that sort of problem. But in this case, none of it has been applied. So yeah, not great. Let's see, is there anything else we want to look at? There's like self file parser. What is that about? Doesn't do anything. Okay. It's probably not implemented. What else have we got? Tiles, tile layers. We can have a look at those, I guess, but I think we've seen the meat of it. Yeah, this is building a... Okay. I think there's some resources here. Res textures. Okay, yeah, let's quickly look what they look like. They're like wall, inner, corner, bottom. left, right? Let's look at one of, bro. Let's look at one of those. Oh, wow, that's tiny. Okay. Yeah, okay, it's right there. I don't think you can even see it. I'm not gonna open an image editor right now, so, but yeah, you can probably imagine they probably look like just little pieces that get sort of composed together. Let's look at the shaders as well. Vertex, simple, avert. Let's look at it with some sort of syntax highlighting because it's kind of miserable otherwise. Okay. Some uniforms. Oh, I remember this. Okay. I do specifically remember that SFML does not support shading properly, like shaders very much. You kind of have to hack it onto it, which is why there's nothing more complicated. Here, there's just like what is it? A linear fall off or something for the shadowy thing that we saw in the game, where it's like a sort of vignette around the player, but it's like super tight. Yeah, I don't know. Getting this to work was kind of a pain. I remember that. This is something I specifically remember. So yeah, we're not gonna shit on this too much. Okay, what else have we got? We got fragment shader as well. Simple.frag. Yeah, okay, so this generates the fall off between the vertices so that it doesn't look pixely. Yeah, fair enough. So I think in general we've seen most of it. I don't know if this video is interesting, to be honest. It might not be very interesting because I'm just sort of jumping between things a lot, but I'm gonna upload it anyways. See what sticks, right? There's a lot of sort of boring logic in here that I don't really want to review because it's like, how else are you gonna do it? I mean, you know, in general, this whole engine needs a better design. There's a way too many classes here. There's way too much stuff going on. I see that there's an event. Let's look at the events thing. The events is like a sub repo that I've written that's apparently MIT licensed. Cool. That does. Oh. Okay. This is just synchronous event handling. Like you basically have events and handlers for events, but completely entirely without any event loops. So neat. I mean, it's cool. I don't see why you would use this, honestly, unless you're like trying to, as I said, trying to do everything from scratch and learn. Then this is not something you would use. If you're just trying to make a game, then please just use an existing one. Like there is Boost Signal 2 is great. There is some other signal library, 6slot or whatever it's called. They're all pretty good. You do have to watch out if you're using threads. Once again, same thing. Boost ASIO is great for this sort of stuff as well. If you need like an event-driven thing, it's very performant from what I could tell. There's a Vector2 library here that I had thoroughly reviewed, like that I asked other people to thoroughly review, and it's just a bunch of math. And again, don't do this. Use GLM or some other library that actually does math for you, because this is heavily unoptimized. And math is the only thing that you don't want to have to write yourself unless you're trying to learn it, right? Yeah. I think in general, this is a pretty good attempt, especially for me from 5 years ago. I was a fucking noob. I think I just started, I don't know if I just started uni. When is this, 2019? Yeah, I must have just started uni. I had no idea what I was doing pretty much. I had learned Python and then C#, and I was just getting into C++. It's probably the first year of me learning C++ that I've built this, which is pretty cool. I think that's a good pace to learn at. Yeah, if anyone else trying to build an engine, let's get the repo in here. This is the repo. You can have a look at it, but it's definitely not great, and you're not going to be able to compile it because it's not great. But yeah, I guess you can learn from it. I know that there's a bunch more stuff to review in this, like the iRigid body interface. It's all stuff that really you shouldn't build yourself. And so that's just most of the thing, most of the things that I'm gonna say about this engine is like, don't build it yourself. Don't build the rigid body logic yourself. Use like Box2D or whatever. Like you use libraries liberally to do the job for you. Because the reality is, if you build all of this yourself, you're going to burn out and just not do it. Like I did here. Like this is I've started this. This has 23 commits, and I just kind of gave up because it's just way too much stuff to build. Like, every time you want to add a feature, you're like, oh, I have to now build the collision logic for round objects. And oh, I have to now build a matrix math into my vector library because I'm going to try to I don't know, do proper model view projection stuff because it's easier, or I want to switch away from SFML, so now I have to rebuild everything. Like, just use stuff that is already existing to build your engine if you want to build an engine to make a game. Which probably I wasn't trying to make a game, I was probably just learning, I don't remember, but yeah, try to do that. And this is way too fucking long, this video, but I hope anyone who is still here still enjoyed it. And yeah, I'm gonna call it here, guys. Have a good one.